Hi everyone, Mr. Michael here. In today's video, I'm going to show you something similar to what I showed you in my previous video around calculating future value annuities. In the previous video, we were starting with nothing, so basically a present value of 0. Today's video, I'm just going to go through two more examples where, again, we're looking at those future value annuities, but this time we'll be starting with an initial investment, keeping in mind that this will be our present value, our initial value that we start with, the principal, but we're going to be putting in a negative number because it's money that we're paying into that account, okay? So just keep that in mind, that we're entering in a negative value as a present value and negative values as our PMT values, our payments per period or per term, because we are paying those into an account there, negative values that we put into the calculator. So, my first example, we have a person here that has made or makes an initial investment of $5,000 into a saving account and followed with regular deposits of $250 at the end of each month. The account paid 8% per annum interest compounded monthly. So let's go ahead and work out the values that we're going to put into the calculator, starting with the number of periods that the money is invested for. So it says here we are investing this for 10 years, and the money is being compounded monthly, so 10 times 12 or 120. The interest rate that we're going with is 8%. The present value that we're going to start with in this case is minus 5,000 that we're putting onto the calculator. So that's the initial investment, $5,000, but don't forget to make it a negative value when you're entering it into the graphics calculator. The PMT, so the amount that you're investing per period, in this case per month, is $250. Again, that's going to be a negative value, so negative 250. It's actually asking us to find the account balance or the future value. So that's something that we don't know, that we're asking the calculator to find for us. And again, the payments per year in terms of the interest payments per year and the compounding periods per year will both be equal to 12 because it is compounded monthly, okay? So to determine the PY and CY values, looking at how often the money is compounded. So after 10 years, how much will be in the account? In your graphics calculator, again, we're going to be using that finance function. So enter there. Once you're in there, we're going to be using the compound interest function here. Again, I'm going to touch on the F4 function, amortization function, and show you a few things there. But let's start by entering those values here into the compound interest section. So N, number of periods, is going to be 10 times 12. Okay, you can put in 120 or put in 10 times 12. It'll do it for you. The interest rate, 8%. The present value, as we said, was minus 5,000. PMT, so the amount that you're putting into the account every month, $250. And P/Y and C/Y already set to 12. So we then just ask the calculator to determine the future value for us by pressing F5. And it will tell us that after 10 years, based on an initial investment of $5,000 and depositing $250 per month at 8% per annum, compounded interest compounded monthly, we're going to end up with $56,834, and we're rounding that up to 71 cents. So $56,834.71. I hope I got that right. I get my memory. Good. So that's question A done. We've calculated the balance at the end of 10 years. Then we also are asked to calculate the interest earned. Okay, so how much of that $56,834.71 is interest? And basically what we need to do to work that out is to subtract how much money we've actually deposited into that account. So we started by depositing $5,000. So to determine how much interest we how much interest we earned, we're going to, from that amount, subtract. So from the future value of $56,834.71, we're subtracting the initial investment of $5,000 because that's not interest that we've earned, that's money that we've deposited. And we're also going to subtract the monthly deposit of $250. And we did that for 10 years every month. So there was 120 lots of $250, okay? So that's where I got that amount from. Now, of course, you can put that into the calculator and you'll get an answer of, all right, I think it'll work out to exactly $21,834.71. Or another way of doing it is to use that amortization function within your graphics calculator. So from here, if you exit back out to that main menu, it's still in the finance, or not the main menu, but the menu within the finance function, and press F4, notice that it's actually already copied all that stuff across in terms of the number of periods, the interest rate, etc. So it's all there. All I'm going to do is put in PM1 and PM2. Now, PM1 and PM2 refer to the period number. So I want to know how much interest is earned from and including the first period up until the end of the 10 years, which is the 120th period. Okay, there was 120 periods in total. It says it there, a value of N. So from the first month inclusive up until the last month inclusive, how much interest was earned. I then press F4 here, which gives me the sum of total interest in that time, and it tells me that the sum of total interest is $21,000, as I said before, $834.71, meaning that the amount of money that I actually invested into that account over the 10 years, including the initial amount of $5,000, works out to be the difference between these two amounts, right? So that would work out to $35,000 that I deposited or invested over the course of the 10 years into that account, okay? One last thing I just want to show you again in that amortization function is, and this is the tricky part of this function, is really understanding that these PM1 and PM2, we're talking about how much interest is earned from a particular period, inclusive of that period. So let's just say, for example, that I wanted to work out how much interest I earned in the last year, okay? So I'm asking it to determine how much interest, what's the total sum of interest in the last 12 of those periods for me, the last 12 of the compounding periods. So rather than putting in 108 as PM1, I'm actually going to put in 109, because if you count 108, including the 108th period, it actually works out to 13 months, okay? Because it is inclusive of the 108th period, or the 108th month of my investment. So I'm going to change that to 109. So this then tells me the total number, the total amount of interest that is earned in the last 12 months, the last year of this investment, okay, by pressing total sum of interest from the 109th month, including that 109th month up until and including the 120th month. Okay, so F4 tells me that in the last year, the interest earned is $4,229 and 67 cents, or you could round it up to 68 cents if you like. Okay, rounding up is not an issue because we are talking about there being more than 67 cents. Anyway, that's, I guess, the important thing to understand when you're using this function, that the PM1, PM2, we're talking about a period from and to, but inclusive of, okay? So that's just one thing to look out for if you are using that. Now, the second example I'm going to go through here is this person, Jill, deposits $200 per month into an account, pays 5.5% per annum, compounded monthly. Find the value of the account after 4 years. So in this case, we actually don't have a a starting point, but for the question B, the starting point will be the amount that's there after 4 years. So we'll get to that in a second. But for this, the first part of this, number of periods is going to be a 4 years times by 12 because it's compounded monthly. The interest rate, as it's given to us there, is 5.5%. The present value, or the initial amount that's being invested, the initial principal in this case is going to be 0. The payments per term, regular payments will be $200 per month. So again, keep it as a minus or a negative value. The future value is what we're asking it to determine for us. Again, and PY and CY will both be 12 again because it is being compounded monthly. Okay, so find the value after 4 years, put that, all those details into my calculator. So 4 times 12 for the number of periods, compounding periods, 5.5 for the interest rate, present value of 0, the regular payments of $200 per month, and the future value is actually what we're asking it to determine or work out for us. PY and CY are both remaining as 12. So again, to solve for the future value, press F5, which gives us $10,710.57. Okay. So that's how much money is there after 4 years. But B, the next part of this question says, after 4 years, Jill receives a promotion at work. So she increased her deposits to $300 per month. Find the value of the account after 3 years of the larger deposits. So after 4 years, there is $10,710.57. The interest rate remains the same at 5.5. This amount, $10,710.57, becomes my present value. The payments per term now increases to $300. The future value is what we're asking after 3 years. So this number of periods would then be 3 times 12 because it's still compounded monthly. PY and CY will still remain as 12. So let's just write those numbers down. Number of periods is 3 times 12 or 36. Interest rate remains at 5.5. My present value now becomes the amount I worked out in part A. The payments per term increases to $300. The future value is what I'm asking it to determine for me. PY and CY, again, remain at 12 because it's still being compounded monthly. So I'm just going to go and change those values. Number of periods to start with becomes, as I said, 36 or 3 years compounded monthly. The interest rate remains the same. The present value that we're starting with is now $10,710.57. Now remember, this is still going to be a negative number, so put it in as minus $10,710.57. The amount here has increased from 200 to 300, and yeah, we're then asking it to determine the future value for us. So I can set that as 0 or just press F5 here, and it'll tell me the new future value after those 3 years is going to be $24,340.21. So let's get that up again. Sorry, $24,340.21. So that's it, guys. That's how you calculate those future value annuities using your graphics calculator. And if you can, make sure you have a bit of a play with that other function within the graphics calculator, the amortization function there. Yeah, be careful. Make sure you understand that within that function, PM1 and PM2 are inclusive of those periods or those numbers that you're putting in. Okay, so just be careful with that. Have a bit of a play with it and make sure you're checking your answer to get the right answer. Yeah, again, if you've got any questions, drop them in the comments below. But thanks for watching, and hopefully that helps.